To you yesterday, I received a couple of emails from some of you, and they were asking me about, for example, some tips on plotting those reciprocal functions of the linear functions. And it just came to me that maybe because of the COVID, because those things were supposed to be given to you while you were at the level 3, then it came to me that maybe because of the COVID, there was some kind of irregularity in the learning experience. Then I moved so fast to prepare you for the future sessions that we're going to have and also the next year. Because all the things that we have done so far, it was supposed to be covered for math level 3. Then the thing which I'm going to do today is that I have given you a handout, 2 pages. I'm going to solve for you the one which you see on the first page, A. You do part B today. Then I move on. We have only 1 page? Yeah. Uh-oh. Oh, my bad. I put it for 2 pages print. Let me see. Oh my God. The second page, it didn't just go to the print. I'm going to put that for you on the board, no worries. And also for the second page, I'm solving the first one. You do not see yet. I'm going to put that on the board. Then you solve the second one here. Hopefully we can finish it today. And please listen, it's a very important one. Okay, let me do one. Let me put the first one for you, then I do this one. Okay, I'm going to plot this function. Okay, please everyone listen very, very carefully. This is a very interesting part. It's a kind of a review. Please make sure that you take detailed notes because you're going to go back to do part B or A. Then when we go there, please be very proficient. Okay, I'm just going to do that as an algorithm that normally what we have done. Okay, guys. The question was that we have covered so far is that, for example, to plot this function. That's the thing which we have seen in level 3. But now, in order to plot it, I'm going to take a look and I see, oh, look at that. I can take a look at the one which is at the base. This is an inverse function. And first of all, I start with the function which is the forward, which is going to be 2 minus x. This function plotting it is so easy. I'm going to develop an algorithm for this, then take that algorithm right over here to just plot this one. You see that they are exactly the same. The first thing that we do, step number 1, we know that we have to find the domain. And the domain for this function is what? I'm going to write it with a different color. The domain of the function f of x is all the real numbers. The second part, Ash and Daniel. The second part which I'm going to do with this is that very easily come to find the intercepts. Daniel, I can hear you. Intercepts. The intercept is so easy. I have 2 intercepts. One is x-intercepts. The x-intercepts means the plot just plots the x, which I know that I should say x equal to 0. Then I get what? What is the x-intercepts? For x-intercepts, you put y equal to 0. Because I'm looking forward to see what is that. Then you see that the x-intercept is this one. You put f of x equal to 0, then you get x equal to 2. And also you have y-intercepts. With this type of a function you have seen, you put x equal to 0, you get f of x equal to y. Y-intercept is also 2. Okay, now, the next next step is this. These two steps, please listen to that very carefully. We are going to use that when we come to the inverse of the other functions. We identify the intervals of being positive and negative. I'm going to use that part when I just go to the other function. Look at this. What does it mean? So far so good, everyone. Any questions? No, everyone is happy, happy, happy? Look at this. Now, I have this quadratic Cartesian frame. So far, by knowing I should say the domain and knowing the intercepts, I can plot that function. And if I want to do that, you know that this is 2, and I connect them, I know that the coefficients of this one is minus, then it means that the function can be plotted something like this. Now, and this is 2 plus 2. Now, look at this. I'm just going to find, oh my god, this board is too small. Look at this. Now, at this system, which is very important, I'm going to use that triage for the next function is this. I come to look at this function, find the intervals that the function is positive. Where the function is positive over there? It means that the function is positive means what? Means that the plot is located above the x-axis, that wherever you are on the plot, you look at the y-axis, you see a positive number. You see that? If you are from minus infinity all the way to the plus 2, you see that the function is above the x-axis, which means that the function is positive. Yes, Caitlin? Now, then it means that the interval x less than plus 2, the function is what? Positive. I wish if I had a different color. And after 2, the function is negative. You see that anywhere you look, anywhere you are along the plot, you take a look at the y, you see a negative number on the y-axis. Yes, Alex? Now, then it becomes, then you say that x greater than 2, the function is negative. This is very important to keep track of the intervals that the function is positive and negative. Now, my friends, I'm going to the very last step. I'm going to find the intervals of increasing function and decreasing function. What does it mean? You find that level 3. I'm going to see where the function is going to increase, where this is decrease. Look at this. It means that, for example, if I'm standing here, it's me over here, I'm walking towards the positive directions. As I go much closer here, as I walk along, anywhere as the x is getting bigger and bigger, for example, now I'm at minus 10. Now I go to the minus 2. I see, for example, this value of the function y. When I come here to the bigger x, x becomes minus 2, it becomes plus 3. Then I see a little value of the y. It means that the function is decreasing. Also, you remember it from the level 3, because it is minus there, it's a decreasing function. You remember that from the level 3, that any functions y equals to minus ax plus b, that a is minus, is a decreasing function, and any function y equals to plus ax plus b, because that's the positive, is an increasing function. Then you can see that from minus infinity to plus infinity, the function is what? Decreasing. I haven't done any fancy thing yet, except these are the things from level 3, which I hope that the Zoom sessions and the COVID didn't impact skills learning this stuff much. But there are very important steps. Seems very easy. I'm going to use it all the way to plot that function. Any questions, guys? Everything is fine over there? Calvin, Jackson, Nick, Priyash, Russell, Daniel, Alex. Oh, Misha. Alex, Liana, everything is fine. Caitlin, Angelique, Lauren, and Medina. And Daniel and Ash. Everything is fine. Awesome. It means that I learned everyone's name eventually. Except you and your sister. Sometimes I call her Tuna, sometimes I use these names. Okay, now I'm just going to the next. Any questions so far? No? Okay, wait a second. What was the function which I was planning to plot? 2 minus x. Look at this one, guys. In order to plot this, I build the strategy to plot it based on this function. That's what I recommend to Laura and Caitlin. When you want to find, it's and. Oh. Weird handwriting. Now, look at this, guys. This is now our session really starts from now. You say, why? I tell you, because I know how to plot this function using these 4 simple steps. I'm going to take everything from there, copy it here. What does it mean? First of all, I'm going to find the domain of this function. What is the domain? I take care of this part. I know that x is a dangerous thing if x goes to plus 2. Because if x goes to plus 2, it becomes 1 over 0, and I hate that thing to happen then. Then what does it mean? It means that the domain of this function is what? Is all the real numbers, however x cannot be equal to 2. That's the first thing. From there, I added, look at this, I didn't have that step here. I'm going to squeeze one more step into there, and I find 2 things. First, from here, first of all, I get x equal to 2 as what? As my vertical asymptote. I call this vertical asymptote. And also, I know always, I did prove that to you yesterday, but we do not need to know the proof. From now on, at level 4, advanced function, we always assume that y equals to 0 because becomes our horizontal asymptote. We always memorize. It's always like that, without any exception. And I proved that to you yesterday. Any question on the first step? Yes.
So you're saying that any problem we get like this, the horizontal asymptote will be
It's always y equals to 0.
Okay.
And I proved that to you yesterday. Why?
Yeah.
Awesome. Now, the next step. Let me use my fancy squares around. Sorry, what? This case is always 0. Let's wait, Calvin, wait at the end of the class. I give you a general formula that you can just always find the horizontal asymptotes any number. But for this case, because the derivative of this one is 0, the derivative of this is 1, it always this is 0. Now, the next step, I'm going to find the intercepts. Look at this. I haven't done anything yet. Find the domain, find the domain. Nice. Find the intercept, I'm going to do the same thing. What is going to be the intercepts? I have two intercepts. X intercept. X intercepts means the point that it crosses the x-axis. As a result, it has a y which is 0. It means that I put, look at this, in order to find the x-intercept, I put f of x equal to 0. Then I have to solve this equation. 1 over 2 minus x becomes 0. Anybody is here who can solve that problem? Then I give him, if you find a number, I give him $2,000. Anybody can solve this? Because if you solve it, I get the medal in the math, then I win $1 million, I give you $2,000. That was the reason. You cannot solve it because this equation has no solution. You never find 1 over something becomes 0. Yes? Yes, Alex? Why it becomes 0? Because I know that if something over a function becomes 0, it means that that something has to be 0. 0 over something becomes 0. You can never find 1 becomes 0. 1 is a number itself. Then this equation has no solution. Does it make sense to everyone? Don't be shy. If you have some problems, let me know. Raise your hand a little. You're fine, you know? Everyone's fine? Then as a result, I say that there is no x-intercept. How about the y-intercept? Do I have a y-intercept? For y-intercept, I do what? I put x equal to 0, then I find how much is going to be the y. If I do that, I have 1 over 2 minus 0, which is y over 2. Then y over 1 over 2 becomes my y-intercept. Now, I'm not, yes.
Would you know that your x-intercept can't be 0 anyways, just because you already said you're horizontal asymptote?
Oh, no. Horizontal asymptote, I told you, it becomes, for example, you get close to it, but you do not cross it. Then that's why asymptotic behavior is different from intercepting of the plot.
Okay.
Then do not confuse this one with this. There are two different concepts.
Okay.
Because with the intercepts, look at that. The palm of my hands, for example, this is, guys, look at this. This is the x-axis, and that's the plot. Look at that. When they are asymptotic behavior, Daniel, they are coming, look at that, to this. They are just getting as much as close. But the x-intercept is that. You have your hands, it becomes the plot, cabling, and this is the x. In the intersection, it becomes like that. It crosses it, but with the asymptotic is this. Make sense?
Yeah.
Awesome. Now, I go to this part. This is very important. These two steps, when it comes over there, please take notes. The next step, it becomes this. I find the intervals of positiveness and negativeness. Intervals, I put positive and negative. I don't write it, say sometimes. Guys, look at this. Guys, everyone please listen to this. It's very important. Russell and Priyash. I'm looking for the positive and negative intervals. I'm not going to find it here. I go back to the solution which I got from here. Yes, Laura? It's impossible to find these intervals right from here. Russell, it is impossible to find these intervals from the function itself. That's why I have to come back to the function which I solved before to find these intervals. Look at this, guys. If I have, let me write it here. Guys, if I have something which is positive, which is this, how did I get from here to here? I flip the function. If I have something positive, if I flip this and becomes 1 over positive, is it still positive or negative? Look at this, I have something positive, I flip this to this expression, 1 over positive. Is it still positive? Or if it was negative, 1 over negative, is it still negative? Now that's the thing. I look at the intervals, which is x less than 2, which is positive. If I flip the function, still this interval is positive. Look at that, something is positive, you flip it, this is still positive. Then if the original function was positive at x less than 2, when you flip it, these functions are still going to be positive at here. Then, whatever answer you got, the intervals are positive or negative. From here, you copy it and paste it there. Make sense? Then for this, I'm going to say x less than plus 2, it's the positive interval, and x greater than 2, it's going to be negative. Now, the last thing which you do before you just go to solve one of those problems on your own is this. The intervals of increase or decrease. Now, I'm a little bit lazy. Increase, I show it like this. Decrease, I show it like this. Goes up, goes down. And now, look at this, guys. This is the last 50 seconds of the course for today. Then you just go on your own to solve one of those things on your handout. Look at this. If something is going up, it means it's increasing. You flip it. Becomes this. When you flip it, for example, you have $20. Now imagine your money becomes 1 divided by $20 becomes 20 cents, for example. The thing which is high, when you flip it, becomes small. Does it make sense? Something is increasing. When you flip it, becomes what? Decreasing. Or when something is decreasing, you flip it, it becomes what? Increasing. That's why they call that reciprocating. Something is increasing, you reciprocate it, it becomes decreasing. Then as a result, guys, in order to find these intervals for this function, I cannot find it from the reciprocated function. I go back to look at this. I noticed that because I had a linear function. Along the x-axis, from minus infinity to plus infinity, the function was decreasing all the time. Then it means that I copy-paste it over there, and I noticed that if something was decreasing, when you reciprocate it becomes what? Increasing. Then it means that I copy-paste it from here, and it means that from minus infinity, let me write it like that. X belonging to minus infinity to plus infinity, f of x is what? It was decreasing here. You flip it, becomes what? Increasing. Excellent. Now, I've done. Everything I needed is done. I give you 2 hours to write, but I want to erase this part.
2 hours to write?
Oh, sorry, 2 minutes. Oh, actually, I have a replacement today, right after this class. It means that 2 hours after this, I have to rush to the another class to meet for a replacement.
I'm working for
different two concepts, right?
Any questions, guys?
Keep talking, and it takes one over X. It's like, oh, yeah, what's up on that? Because one over that.
Any questions? Now, if you have no questions, I want to ask you, please, everyone's eyes on the board. Do not even blink. Take a bit more time to write, or? Oh, sure, please. Then after, everyone's eyes on the board, even do not blink. It's getting very exciting. Look at this. Awesome. Thank you. Look at now. First step, when you're producing the same thing on your paper, do this. First step is going to be this. I say that. First step, I follow these steps, copy paste it on the other sides for the reciprocate function, and Lauren and Medina, now I'm gonna plot it. The first plot, which I erased it before, it was this one, for the forward function. I had the x-intercepts 2. Jackson, I had 2 intercepts at the y, then I connected them together. I got the plot of this function with the blue. Now, I'm going to plot that function, but it's not going to be a hard thing because I have all the information which I need, and I tell you how I'm going to use it. The first one, Michelle, is this fact that I identified the domain, and from the domain I identified my asymptotes. I'm going to show the asymptotes on here. What is the first asymptote? X equal to 2. It means that this point is my first asymptote. The second asymptote is y equals to 0. Y equals to 0, incidentally, is the x-axis. These are my asymptotes. Then it was step number 1, which I showed that on my plot. Step number 2, it means what? It means that I'm going to find the intercepts. The intercepts for the x, I have nothing, but for the y, I have what? For the y, I have 1 over 2. This is 1 over 2. Now, Rihanna. And now I go to the third. Alex and Rihanna. I go to the third. I look at the intervals that the function is positive or negative, and also the interval that the function is increasing or decreasing. Still, I know that before x equals to 2, the blue function was what? Decreasing. And after 2, the blue function was decreasing. It means that if I'm going to plot this function over here, I notice that the function has to be what? Has to be still positive. Sorry, I was talking about the positive. I have to talk about positiveness first. Before 2, the function was positive, and after 2, you see that the function becomes negative. That's what we got here. We copy paste it there. Then it means that before I reach to this point, this function should be on the top of the x-axis. That's what it means there, huh? But it means that after 2, when the x is less than 2, the x is greater than 2, the function becomes negative. The 2 is here. After 2 means the function is negative. It means the function should be here, below the x-axis. You got this one? The implication of this one here? The fourth one is going to help me to plot it. It says that the function is going to be all over the place increasing. Then it means that when you start, for example, the function is going to be increasing. It means that you put your hand anywhere like this, and you try to just, go up because the function increases. But how the increasing behavior shows. First of all, I know that I'm going to start from here. Now I'm going to plot it. Everyone look at this very carefully. I know that before 2, the function is positive. Means that I'm going to start over here, not here. I have to be above this. I have to cross +2 because that's my intercepts. The function is increasing and closes my asymptote. And that's the concept of the asymptote. I start from here. I make sure that I just cross the y-intercepts, then goes all the way up there. Also, for the x greater than 2, look at this part. For the x greater than 2, the head the function has to be decreasing. So the function is negative. It means that the function is going to be here. And also increasing. It means that I start from here, I have to be below the x-axis. I know the function increases like this. I have to look at this. I just get close to the asymptote and increase. Look at it, the function increases, goes to the other asymptote. And now the function is plotted. Oh, beautiful. So beautiful. And now, any questions? Are you sure how did I use these two intervals to plot this? Everyone is okay with this? Now, before you get it, how about you? You're fine? Now, before you forgot it, please go to your handout, plot the second one. No, plot the first one. Do the second one as a homework. Plot the second one, and I do recommend you do exactly like this. Yes?
Should I plot the first or second one?
The first one, do the second one at home.
Okay, thank you.
Thank you. And let me pause the recording because you don't want to see I'm walking. Okay. The task is this. I'm going to just plot this function. It's part A on the handout. But before I do this, I take the one at the denominator. And guys, look at this. I take the one at the denominator. And let me just say something. For the second one, which you have to do this on your own, if I have 1 minus here, which you have it on your part B, take minus with this to take it as the forward function. Do not leave the minus over there alone. Take minus with it, bring it over there. We do not have the minus there, then that's right. Yes?
So it would be minus x plus 7? Like
That's right.
Okay.
Then it becomes minus x minus 7. Guys, listen to this. It's very important. Part B, which is going to be your homework, it has a minus on there. Take minus with x minus 7, bring it over there. Now we do not have minus, then I put x minus 5 there. Everyone listen. Lauren, Angelique, Medina, Nick, Calvin, Jackson, Russell, Ash. Oh, called everyone. Look at this. Now, look at this. I'm not going to do anything. You see how easy is that going to be. First of all, Ash, the domain of this function is what? Always R. The linear function, the domain is always R. I go to the intercepts. I'm looking for the x-intercept. Means that I have to put f of x 0. Means x minus 5 becomes 0, which means x is what? 5 as my x-intercept. Now, Daniel, I'm looking for the y-intercept. The y-intercept is what? I put x equal to 0, then Russell, then y-intercept becomes 0 minus 5, which is minus 5. At this stage, That's all I need to know for the linear function to plot it. I have y, I have x, I have 0, and I noted that the x-intercept is 5, and the y-intercept is -5. I know that, Alexandra. I have to connect these two things to plot the function. Now, I move on. I look at the intervals that the function is positive and negative. Look at this. The point that the function is standing above the x-axis, Nick. This is above the x-axis that the function is positive, Daniel. Is x what? Greater than 5. Then, the positiveness of the function is where x is greater than 5. Because x, Caitlin, greater than 5, you see that greater than 5 is all above the x-axis. And that's why x greater than 5 is positive. And you see that when x is less than 5, which is standing here, the function becomes negative. Now, the intervals that the function increases or decreases. Look at this. The function, if you're standing here, walk along the x-axis, you measure your y, you see that the y is getting bigger and bigger and bigger. One reason. The second reason is that the coefficients of the x is positive. Then it means that along the x-axis, the function, Lauren, is always what? Increasing. Now, I get everything from here, bring it all the way down there for this reciprocated function. Priyash, look at this. For this function, I'm going to find exactly the first step here was domain. The first step is exactly the domain. But the domain is this. The point I put x equal, x can be any real number, Rihanna.
Yeah.
But x cannot be equal to what? 5, which is the root for this, because if I put 5 there, Priyash, 5 minus 5 becomes 0, and that's the disaster. Then domain is not less than 5. Then the x, the vertical is x equal to 5, and I know the horizontal asymptote is always in this level is 0, y equal to 0. What is the x-intercepts? Do I have x-intercepts? No, because I know that 1 over x minus 5 never becomes 0. There is no x-intercept. What is a y-intercept? Y-intercept is the place that the x is 0. Then I put x equal to 0, I get 1 over minus 5, which is minus 1 over 5, which is my y-intercept. Now, look at these parts. These parts are my favorites. The intervals of being positive or negative. As I explained that before, whatever interval you have, which is the positive, Alexandra, and negativeness of the intervals, of the forward function, you copy paste it there, it becomes x greater than 5. It becomes the function positive, and x less than 5, the function is negative. Because if something is positive, Ash, you flip it. This is still positive. Now, Ash, look at this one. I noticed that the function is always increasing along the x-axis. When I flip it, Caitlin, it becomes decreasing. Imagine something is getting, let's say, increasing, the volume increases. When you flip it, it decreases right away. And that's the only thing. They have opposing behavior, Jackson. Then if, at this interval, the function was increasing, when you flip it, the function what? Decreases. Correct? Now, I go to the part to gather Lauren to gather everything from here to put it here to plot it. First of all, I noticed that the x equal to 5 is my what? Is my, that's right, vertical asymptote. Now, y equals to 0, it's also my horizontal asymptote. Guys, please do not harm. And now look at this. My y-intercept is minus 1 over 5. For example, this is this one. Minus 1 over 5. I said that if x is less than 5, which it means that I'm here, the function is what? Negative. Means what? I have to be in this area before 5. The function should be below the x-axis because the function is negative. However, Nick, after x greater than 5, let me see, x, that's right, x greater than 5, the function is positive, it means it's here, above the x-axis. However, x less than 5 is on the left side of this slide. The function is negative, means that it should be here, below the x-axis. Make sense, everyone? Now, and also I noticed that the function is always decreasing. It means that if you start from here, the function decreases. It means that you put your hand here, and you just bring it down. The function decreases. It goes in that direction. Now, let's plot everything. I know my vertical asymptotes. Look at that. I'm just going to start from this vertical asymptote, and I know that the function is decreasing. And it means that I have to, after 5, the function is positive, means it's over here. Then it means that I have to draw it somehow, that in the vertical asymptotes should be close to the function which I'm plotting. One vertical asymptote is this, one horizontal asymptote is this. The function has to be above the x-axis after 5, and the function is decreasing. It means that you start from here, and you go all the way there. It's the first pair of the function. Yes, Daniel? Look at this, after 5. The function is positive, this is above the x-axis, and also this is decreasing, because you start from somewhere, and the function, you bring your hand down. Now, how about what happens at less than 5? We know that the function less than 5, the function is negative. Means that you have to plot it below the x-axis. That's right. Now, I plotted below the x-axis, and I know that the function again is decreasing. It means that you start from your horizontal asymptote, never forget your asymptotes. You go all the way there, cross y-axis at minus 1 over 5, then go all the way towards the other asymptote. Do not cross it. Go like that. These green ones then becomes your plot. You see that I didn't do anything except I translated everything from here and I put that on the graph. Make sense to everyone? Michelle, any questions?
Oh, no, not about this. No.
Danielle? Alexandra?
I don't think so.
Rihanna? The plot is okay? Brilliant.
Yeah.
Michelle, Caitlin? No questions? Sure. Angela? Fine. Alright. You're fine. Dina? Great job. And Jackson, how about you? Fantastic. How about you, Nick? Fantastic. How about you? Fantastic. Ash, oh, I love you. That is the technology. And oh, you got how you just do
Because if you listen to this
We understand.
because when you say like,
The asymptote is confusing.
Oh, if you like, don't you have gloves on?
Better question. Better question.
Mr. Rosati,
Yes.
I have a question for the second